Okay, this document is being prepared for the Prison Mathematics Project. I realize there may be people watching these videos wondering, how do I get that document? Well, you may want to reach out to me. The document's not published at this point. But my name is Ron Bannon. My email address is Bannon, that's B as in boy, the @ symbol, NNON.US. And certainly this series of problems over here is a little bit different than the prior ones in a couple of different respects. One respect is I see that there's certainly some calculus questions over here, and I also see it's longer. And I want to claim in a competitive exam, in some respects, it's better to have a longer exam. And the main reason to have a longer exam is it gives more choices. Like, don't ever think you have to complete all the exam to get credit. You do what you can, right? I really mean that. Do what you can, including if you're just, partially doing something right. That's not a bad thing to be doing, by the way. But what I want to do is I want to concentrate on a particular problem over here. And the reason, because I'm looking at this problem set, and I'm going to say, at least today, I'm seeing this as probably the easy problem for me to handle. I could be dead wrong, by the way. I could be looking at something and saying, that's not the easy one. Maybe something else is. What I want to do, well, I notice I highlighted this over here. I guess I should talk about that. I'm going to talk about this right over here. This, brief solutions in video format are available if you have access to the document, by the way. I also think at some point in the future, I'll be publishing the LaTeX form of this document. And the reason for that is some people want to adapt this material to their own classes, right, given to their students, but they want to rearrange things, maybe change numbers, whatever. All right, let me see if I can do this. And I'm out to this problem right over here, by the way. And I'm gonna write things down that I would do. But again, what I do, what you do might be different things. You might say, I'm doing a better thing, you're doing a better thing. That's up to you. It's an opinion as far as I'm concerned. But the way I do something may be different than the way you do it, but the outcomes can't be different, right? The outcomes can't be different. Now, granted, I'm not going to talk about all the details, but I would talk, if I were on a competitive exam, what I would be doing first is I would be squaring both sides. Now, someone says, why would you do that? The radical looks like it's really tough for me to handle. So what would I do over here? I do a to the b plus c factorial is equal to, oh, by the way, maybe I should read the question again. It says compute the number of ordered triplets of positive integers. I forgot to mention that. That makes it easier for me. What are positive integers? They're going to be numbers like 1, 2, 3, yada, yada, yada. All right? But, my problem is I'm never that good at arithmetic, but I got to do 28 squared. Well, let's see if I can do that. 8 times 8 is 64. 8 times 2 is 16. And 16 plus 6 is 22. And then I'm going to do 2 times 28 is 56. You get 4, 8, 7. So you get 784. All right? And then I got to start really thinking. And let me get my eraser out. And someone says, what do you mean you have to think? I have to. I have no other choice, right? But I'm going to say that, kind of looking at it, I would work on the C first, by the way. And the reason for that, they said they were integers. So I know there's these things over here. But I'm wondering what integers would be, for me to choose, right, so to speak. And I'm going to say, 1 would work. When I say work, it's certainly a reasonable number because 1 factorial is 1. 2 might work. And 2 factorial is 2. 3 might work. And 3 factorial is 6. 4 factorial is 24. 5 factorial is 120. 6 factorial is, what was 6 factorial? It would be 6 times 120. And 6 times 1 is 600, 120. Wow, you're getting really close to 784. So I'm going to say I would never go beyond 6. So what you have to do now is work your way either backwards or forwards through the problem, right? So I know it's tough, but someone says, where would you start? Start wherever you like. I really do mean that. Start wherever you like. By the way, let me read the question because I just want to make sure positive integers. I probably should include 0. And by the way, if you didn't include 0, I wouldn't be too upset by it. But maybe I should rephrase that question, by the way, and say non-negative integers. Anyway, positive integers will include 0, all right? So I guess I could start with 0, right? So let's put this down. C is 0. And what would this give me? A to the B. You know what? I'm also gonna correct my stuff over here. And I'll put the 0 over here too. A to the B would be, well, C factorial is 1, so 783. Well, I got a real easy solution to that, and that would be, and they're going to be written in the pair A, B, C. All right, A, B, C. By the way, these are the possible C's. I'm not saying it's possible for everything else, by the way. Maybe a triple pair A, B, C. So what I do over here, well, I said C is 0, right? So what's one good possibility? Well, I guess I could take the exponent B to be 1 and the base to be 783. All right. I could keep going and going and going and going. Now, by the way, what I'm going to claim is I did it. And I'm going to say, work backwards, forward really doesn't much matter to me. I will say that, maybe starting here, and it may not be such a bad idea. But let's say you started at 6 for C. I'll write that one down. Let's say you started at 6 for C. Let's say 6 for C. So what would you get? And let's write this down. A to the B plus, well, 6 factorial is going to be a 720. And maybe that's a better place to start. That's going to be 784. I think you're getting an idea what I'm doing over here. A to the B. I'm going to take 720 from both sides to get 64. All right? And that means I took the C to be 6. Question, what's the A and the B now? Well, an easy one would be 64 for A and 1 for B. What's another one I could do? And again, I want to get 64. And it's still going to be 6. I could say 8 squared. Well, what if there's other ones, right? So again, C is 6. Let's see, 8 squared. Let's see. I guess I could do 4 cubed. And why is that? 4 times 4 is 16 times 4 is 64. Are there other ones? I think so. And I'm going to say, it looks like some kind of power of 2, right? So 2 to what power? The 6 power. Well, let's see, 2 to the 6, 2 times 2 is 4, 8, 16, 32. Yes, 64. They really worked out beautifully. All right, so I want to point out these answers are written over here for you. 64, 16, 826, 436, 266. And then, you kind of work your way down, right? You go to 5, then you go to 4, 3, 2, 1, 0. All right? Now, I didn't do them all. I don't want to bore you with arithmetic, but you realize I'm not going to say it was totally manageable, particularly if you had a tough time if you had a tough time with arithmetic, it would be tough. But, I think I really should reword this to be non-negative integers. All right. Okay. Thank you so much for paying attention, though.